In this video, I will show you how to integrate. So what is integration? To simply define integration, it is the reverse process of the derivatives, or it is the antiderivatives of a differential equation. So for example, in derivatives, if we're going to differentiate a function, for example, we have a function of u raised to n, and we're going to differentiate this function. What we're going to do is to multiply the function by its exponent, which is n, and subtract the exponent by 1. And we put du to see that we done differentiating. So as you can see in derivatives, what is given here is the original equation, or the original function. And the result is the differential function. So the integration takes place here if the given function is the differential function, and what we're going to do is the original function. So as a reverse process simply means when we are going to integrate a function, for example, we have a differential function u raised to n du, and we're going to integrate this function. This is the integral sign. What we're going to do is reverse the process when we are differentiating. So instead of subtracting the exponent by 1 in differentiating, now in integrating, what we're going to do is add the exponent by 1. And instead of multiplying the exponent, the function, what we're going to do here in integrating is to divide the function by its exponent, which is n plus 1. And also in integrating, we need to add arbitrary constant, which represent as in mini box, it's represent as letter C. This is the arbitrary constant. So because if we differentiate a constant, it would be equal to 0. So therefore, arbitrary constant would be any integers. And now this is the power formula of integration. Power formula of integration. And this formula is only applicable at n or when the power which is in is not equal to -1, because if it is equal to -1, therefore the denominator, it would be 0, so the equation will be undefined. So in this specific problem, which the power is equal to -1, we have another approach for that, and I will discuss to you from in my other videos. So let's take some example of integration using this formula. So for example, if we ask to find the integral of 3 dx, so think about integrating or think about differentiating an x. So if we differentiate x, the variable x, the answer would be dx, or 1 dx, which is equal to dx. So simply, as it reverse, when we going to integral dx, when we're going to integrate dx, it would be x. So the answer, the integral of 3 dx is equal to 3x. And don't forget to add c. So to simply not to confuse in integrating, if we have a constant in a function, we're going to put it outside the integral sign. So this is our final answer. So how about if we ask to find, or if we ask to find the integral of pi dv? So as what we do the previous example, so pi is a constant, so we need to isolate in the constant. So the integral of pi dv, so is equal to, the integral of dv is simply v, is equal to 5v plus the arbitrary constant. So how about we ask to integrate dy over y raised to 3? So what we're going to do here is to simplify the equation and bring the denominator to the numerator. It simply is equal to y raised to negative 3 dy. So it's become negative because we put it's from the denominator and put it on the numerator. So what we're going to do, as you remember the general power formula of integration, we need to add the exponent by 1. So negative 3 plus 1 would be equal to negative 2, and we divide the function by its exponent, so over negative 2, and add c. So our final answer would be negative 1/2 of y raised to negative 2 plus c. It would be the final answer. And how about if we ask to find the integral of square root of x dx? So as we all know, square root of x is equal to x raised to 1/2. So we need to transpose this one, transform this function into its equivalent function. So it's equal to x raised to 1/2 dx. So also we use here the power formula of integration. So x raised to 1, the integral of x raised to 1/2, we need to add the exponent by 1, so it's become 1/2 plus 1 will be 3 over 2 over, divide the function by its exponent, which is 3 over 2, and add c. So to simplify, we have here 2 over 3 x raised to 3 over 2 plus c. That would be our final answer. So how about we're asked to find the integral of e dx. So as we all know, e is a constant, so we need to isolate this one. So simply the integral of dx is x. So what we do here, so the integral of a dx is simply equal to ax plus c. Will be the final answer. So last, we have your example. We're asked to find the integral of 3x cubed plus 2x squared plus x dx. So what we're going to this function like this is to distribute the integral in the each terms and apply integration power formula of integration. So what we have here is 3 integral of x cubed dx plus 2 integral of x squared dx plus integral of x dx. Then simplify. So we have here 3 times x integral of x cubed. It would be equal to, we need to add the exponent by 1, so it becomes 4, and divide the function by its exponents, which is 4. And then the next term we have 2 times Then the integral of x squared dx, we need to add the exponent by 1, which become 3, and divide the function by its exponent, which is 3. Then let's go to add another term. We have here is the integral of x dx. So we need to add the exponent by 1, so it's become 2 over, or divide the function by its exponent, which is 2, and don't forget to add c. So it's equal to 3 over 4 of x raised to 4 plus 2 over 3 of x raised to 3 plus 1 over 2 of x raised to 2 plus c. That would be our final answer. And this is the content of this video. I hope you like the video. And for other videos related to this topic, please subscribe and check my playlist.